Okay, Heller. You might fall a little bit through this because you are on top of a jar and duct taped down right now. And I'm no J-Rise, but we will give this a go. Okay, so the problem is a motorboat traveling 2.5 meters per second to the east encounters a south-flowing current. The river is 140 meters wide and the boat reaches the opposite shore 320 meters straight downstream from where it started. So it's asking 4 things. How long does the boat take to reach the shore? So time. How fast is the river flowing? So speed. What is the resultant speed? So speed again. And what distance does the boat travel along the diagonal? So distance. So, okay, I'm really hoping that you can see when I move this. Okay, so the thing with these, since you go left and right or east and west, and then also up and down or north and south, I always write the speed equation twice, so x equals x over t. And then this one, side to side, s equals x over t, and this one will be up and down. And then, hold on, I gotta move you up. I'm gonna draw a picture and just fill in everything that the question says. So it says that it's traveling 2.5 meters per second to the east. So we'll draw that boat up here, and then 2.5 meters per second that way. And then it says the river is 140 meters wide, so we'll draw 140 on the top of that. And then the boat reaches the opposite shore 320 meters downstream. So I'll just kind of do that whole thing, and then oh crap, that's supposed to be 320 meters. So that's everything that the problem says. So what I'm gonna do is I'm gonna rewrite these 2 equations that I wrote and fill in the information that we already know. So on the side to side one, I'm trying to figure out where I should do this. Okay. Side to side, we know the speed is 2.5 meters per second, so 2.5 equals, and then we know the distance across is 140, so we're gonna put that on the top, and then all we need for that equation is time, so I'm gonna leave that as t, and then I'll draw the arrows again, so we know it's that one. And then for the second equation, the up and down one again, we don't know the speed yet, or the time, we only know the distance from top to bottom, so s equals 320 over t. I'm gonna get my calculator out. And since, hold on, up and down. Okay, so since the first equation, left to right, only has one variable missing, we can solve for t. So we can rearrange that as t equals x over s. So t equals 140 divided by 2.5, or 56, and then I'll just check that by plugging it in. So 140 divided by 56 is 2.5, so t equals, sorry, not 2, t equals 56. And then the good thing about finding time, when you find time, you can plug it into t for both equations. You can't do that with speed or distance, but the time will always be the same. So we know that t is 56 too. So river is flowing. So question A says, how long does it take the boat to reach the shore? So we have that answer. I'll write those at the bottom here so we leave room. A, t equals 56 seconds. And then we'll come back up here, and then I'll rewrite these equations every time I get new information again, just to keep it easy and updated, I guess. So 2.5 equals 140 over 56, and that's left to right. And then s equals 320 over 56. And now since we only need s in the up and down equation, sorry I keep forgetting to write the arrows, we can do 320 divided by 56 to find the speed, and that comes out to be S equals 5.71. So that answers question B. I don't know if you can see it. How fast is the river flowing? So that answer, we'll write that down here. B, 5.71 meters per second is speed. So there, we filled in all of the equations, all the variables are full. So we don't need to solve for any more variables. What is the resultant speed? So the resultant speed is Pythagorean theorem. So I'm gonna draw this little triangle. So the speed going left to right is 2.5. The question told us that. And then the speed going up and down is 5.71. We just found that. So we need to find this dotted line, the resultant. So 2.5 squared plus 5.71 squared equals 38.8541. And then the square root of that, 38.8541, is 6.23 meters per second. And that is question C. What is the resultant speed? So C is 6.23 meters per second. Okay, and then, sorry, go back up here. Question D, the last one. What distance does the boat travel along the diagonal? So this is another Pythagorean theorem, so what we just did, except with distance. So I'll draw this triangle again down here. So we know the question says, where is it? Up here, that it's 140 meters wide. So we'll do 140 on the top. And then it also told us right here that it's 320 meters from where we started to where we ended downstream. So then I'll draw another dotted line, and then I'll do 140 squared plus 320 squared equals 122,000, and then we'll do the square root of that, and that equals 349.28. So across the diagonal, the boat moved 349.28 meters in total. So question D, 349.28 meters.